let's see some pseudocode for this nearest function. So this pseudocode is going to make absolutely no sense unless you have fully digested this nearest demo. If you have not, rewatch it, try working it out by hand and seeing if you come up with the same answer as me, but you've got to understand it before the pseudocode will be useful at all. So basically, and you could do this many ways. This is just one potential way. We have a nearest method where we give it a node. That's what we're currently looking at. So when we do nearest and give it D, we're looking at D. We have a goal, which is some point, and then we have a best node. So it works like this. If the node is null, we just return whatever the current best is. If the distance to the goal from the current node is better than the best distance to the goal, we reset best and set it equal to n. Okay, no big deal. Then, if the goal is less than n, according to n's comparator, so some nodes will use x, some will use y, and if you have it in higher dimensions, it would be z and w, then we'll say that the good side is n's left child, and the bad side is n's right child. Now, when I say left and right, I mean physically on the page which one's left and right. So left could actually mean down, or it could mean left. And right could mean right, or it could mean up. Okay. So at that point, I've established who's the good side and who's the bad side. I will then call nearest on the good side, and I'll set best equal to the result of that nearest method. And then if the bad side could still have something useful, and you can write this either with the purple line approach or the green line approach, then we should say that the best equals the nearest searching the bad side. Now, the reason that you have to so if you just call this and you remove this if statement, your code will still work. It'll just be slower. And so if you're having a little trouble, you might take out this pruning rule in order to see if your code is working correctly, and then fix the pruning rule later. At the very end, we return best, and we're done. Okay, so that is an approach you can use. So it seems easy. It looks like only so many lines of code, but there's a lot to digest here, and just be very careful as you write your code, and hopefully it won't be so bad. Okay, that's it for the nearest method. Kind of a marathon, but I think an interesting one, and I hope you find it useful. It's a very interesting way to program, neat way of thinking about solving problems efficiently.